This is a connected particles question, which involves friction. It says the diagram shows two blocks A and B with masses 2 kilograms and 3 kilograms respectively. The blocks are connected by a light, inextensible string which passes over a smooth pulley. Block A starts at rest on a rough table. The coefficient of friction between block A and the table is 0.2. Block B hangs from the string 2 meters above the ground. So this is your initial setup here. And then it says the blocks are released from rest. Copy the diagram showing all the forces acting on two blocks while they're in motion. Also show the forces acting on the pulley. So your diagram is like this. So you can imagine here, I will just go over this and you will see, you've got your normal reaction on your block, which is on a surface. Its weight, and its mass was 2 kilograms, so its weight is 2g newtons. The coefficient of friction was 0.2, so your 0.2 R, that's your maximum value of your coefficient of friction. Remember, F equals mu R is a maximum value of friction. And if it's in motion, so if it's moving at constant speed or accelerating, friction is acting at its maximum. And then what's getting this thing going is a tension and string. There's an equal and opposite tension and string pulling on the pulley. You've got your weight, 3g, because the mass of the particle hanging freely was 3 kilograms, so 3g is its weight. Then you've a tension going upwards, and then also you've an equal and opposite tension. So here we have shown the forces on the pulley, T going left and a T going straight down. So that's your diagram, and obviously it will accelerate, the body on the surface will accelerate to the right, and this one hanging vertically downwards, it will accelerate downwards. So what we've got to do in this question it asks us to do is part B, find the time taken for the block B to fall to the ground. So we need to find the acceleration first of all. So we're going to use this diagram and we're going to say consider the whole system. We're going to consider the whole system. Let's make this a wee bit thicker that we can see it. So we consider the whole system and we're going to use F equals ma. So that's my force equals my mass times acceleration. So the force that's getting this thing going is a 3g. Going against that is a t. Going for that is a t. Going against that is another t. Going for that is another t. So these t's in here and in here, they cancel each other out. So we can forget about them. So the only force you've got getting this thing going is 3g. And going against that is 0.2 r. And that's equal to my total mass. And my total mass is this one, 2 kilograms. This one, 3 kilograms. So my total mass is 5. And that's times my acceleration. Okay, we'll look over here, just to do this over here, at your particle A. So this was particle A, and this was particle B. So at particle A, resolve vertically. Your R is equal to 2g. So your force up is equal to your force down. So R is equal to 2g. So let's just fill this in. That's 3g minus 0.2 times 2g is equal to 5a. And let's just sort that out. So that's going to be 3 times 9.8 minus 0.2 times 2 times 9.8. And then divide across by your 5. And I have got a perfect value of 637 over 125. That's my acceleration. Okay, so that's how the whole body accelerates. Now the question just becomes a Suvat question or a constant acceleration question, because it starts from rest. So my initial velocity is 0. This is my body B. My acceleration is 637 over 125, and my distance is equal to 2. And what are we to do? Find the time taken for B to fall to the ground. So we're looking for our time. We're looking for our time here just. Okay, so we're just going to use S is equal to UT plus a half AT squared. So in this case, that's 2 is equal to UT. My U is 0. So that's just going to be 0. And then a half times my A, which is 637 over 125. And that's times t squared. And let's just divide across. That means 2 divided by the half times the 637 over 125 will be equal to t squared. Let's just find my t, so square root of all that. Okay, and I got, when I did that, I got 0.89 seconds to 2 decimal places. Let me just check if that's the right answer here. 0.89 seconds, it is indeed. Happy days, still got it. Right, okay, so that's the first part. And I needed that then to be able to do part C. Part C, the situation changes. Part C says, when block B hits the ground, block A continues to move across the table for a time, and then find how far the block A moves in total, and the total time that block A is in motion. Okay, so you imagine what's happened. This block A, this thing here has moved down by 2 meters, which means this thing has moved 2 meters further along. So it's already moved 2 meters, and we've just worked out it's already moved for 0.89 seconds. We want to find what happens. So I've done a new diagram. This is just my block A. Now notice it's accelerating. This A is different than what it has been. This 0.2r is going to be the same as what it was, because it's still moving. But notice this wee string, I haven't done a straight line, I've done a wiggly line here to show that there's no tension in this string. So what happens effectively, I'll draw my diagram again. You can imagine this thing has now hit the ground. This string goes slack, still goes over the pulley, but there's no pulling force in a slack string. So that's not actually, there's no tension here. That just does not exist. Okay, so that's all you have. So all that is going to happen here is that it starts off with a certain speed, and it will slow down. So what we've got to do, unfortunately, is find the speed at which it was going to start with. So we'll go back to this, and we'll just say we're going to just look at this and say, first thing we've got to do is find the speed that A was moving. And that's when B hits the ground. Okay, so we know the initial velocity of it was 0, and I'm just copying this down from what we had done earlier on. 637 over 125 was my acceleration, and my distance was 2, and we're looking for the speed. I'll zoom in on this again. So that's what we're looking for. So we're clearly going to use v squared equals u squared plus 2as. So v squared equals 0 plus 2 times 637 over 125 times 2. And then we'll work out what your v is. So whatever that is, 2 times 637 over 125 times 2. And then square root of that and see what we get. So, I got an ugly answer here. Right, I'll write this down because this isn't part of my answer, but it's 14 root of 65 over 25. And I would leave it as this. This is a perfect answer for my velocity. We're going to need to use that, pardon me, in a wee second then to find both our extra distance moved and the extra time that it's taken. Okay, but we also need to find the acceleration then when it slows down. So but that will be our initial velocity. Speed that we've just found, that was the speed that A was moving when B hit the ground. So that means that will be the initial velocity for this next stage of motion. But we will come back to this. Let me just circle this. This is going to be very, very important. Okay, now what we want to do is we want to use F equals ma up here. So up here we want to use F equals ma. So anything going to the right, I'm going to assume is positive. So my force is minus 0.2r. My mass is 2, and my acceleration is what we're trying to find. So that's minus 0.2. The r, remember, was just 2g is equal to 2a. A wee bit of working out then. That means minus 0.2 times g would be equal to your a. Your a works out to be minus 0.2 times 9.8. My a works out to be, and that's a nice answer, is minus 1.96. Okay, now we will need to find the total time. I don't know which order this was in. How how far distance. First we'll do distance and then time. So we'll find our, it's now just goes SUVAT questions then. And then my initial velocity was what I've got on the circle. So 14 root of 65 over 25. My acceleration is minus 1.96, and it's a time for it to come to rest. So it's 0, or it's also the distance for it to come to rest. So that's what we're looking for. So again, we're going to use v squared equals u squared plus 2as. So 0 is equal to my u squared, which is 14 root of 65 over 25 squared, and then plus 2 times my minus 1.96 times my s, and then we'll bring that across. That's going to be 2 times 1.96 s, positive now, is equal to, and then let's just work that out. That's going to be a mess. Right, bear with me a wee second. 14, and then root 65, bottom line is 25. That whole mess gets squared, and that works out. When I square that 14 root 65 over 25, it gives me a perfect answer of 2548 over 125. Then divide across by the 2 and divide across by the 1.96, and I get a perfect answer of 26 over 5. That's very nice. So that's 5.2 seconds. Okay, which I don't think is right. Oh, 5.2 seconds, that's the distance. Sorry, 5.2 meters, 5.2 meters. That might be right then. 5.2 meters. And then remember, it asked me for the total distance. Remember what's just happened. It had already moved 2 meters, and then it's got this. So it's gone this distance. So just your answer then is your total distance equals 2 plus 5.2, which is 7.2 meters. And let me just check the answer and see if that's right. Please, please, please. 7.2 meters. Happy days it is. So 7.2 meters. So that's a tough question there. A whole lot of work to do in that one, as you can see. Okay, so that was part 1. So I'll just put a part 1 there. For part 2, same idea. I will just do it again. Bear with me a wee second. Again, it's like a SUVAT question. So a constant acceleration question. Your U is 14 root 65 over 25. Your acceleration is minus 1.96. Your V is 0. And you want to find the time here. I would just do exactly the same again. So I would just use V equals U plus AT. So 0 in this case is equal to 14 root 65 over 25. And then my A is minus 1.96 T. Bring the 1.96 across. It becomes positive 1.96 T is equal to 14 root 65 over 25, and then your t will be equal to, let's just do that out again, 14 times root of 65, and then that was all divided by 25, and then divide across by 1.96, and I got 2.30 seconds, and that's to 2 decimal places. And remember, we've got to find the total time. I think in part B we worked out the initial time to be 0.8, was it 0.89 from memory? See if the memory's any good. Yeah, 0.89, there we go. Right, so 0.89, so total time then is going to be 0.89, which it moved at the start, plus 2.30, and that is going to be plus 0.89 times that, plus that added on to that, it's going to be 3.19 seconds in total. That sounds familiar. .3.2 then, yes, lovely, and that's going to be it. Lovely, done.